Good morning, students. Today I am going to take your physics bridge course class. So today starts with the topic unit and measurement. That is units and measurements. So this topic we already studied and already we know that where we are going to use units and where we are going to use measurements. So in brief, we are going to study units and how we are going to use the units and also the measurements. Right? So before going to start with the topic, first we have to know the concept of physical quantity. Physical quantity. So what is physical quantity? So the quantities which are measurable, that quantities we call as physical quantities, right? So what are physical quantities? The quantities which are measurable, and with the help of those physical quantities we can explain and understand some physical phenomena, right? So that one we call as physical quantity. That is the quantities which are measurable, right? So those are called as physical quantities. For example, the length of the board, that is the width of the board or length of the board, these are measurable. Hence, we call length, width, those are called as physical quantities. And also the distance. So distance is measurable. Hence, the distance is also called as physical quantities. That is the quantities which are measurable, right? So that quantities are called as physical quantities. For example, I already mentioned, so I want to measure the width of this board. Hence, here width becomes the physical quantity, right? And also, I want to measure the length of this board. Hence, the length becomes the physical quantity. Here length we are going to measure. So we can measure the length of the board and also we can measure the width of the board. So these are quantities which called as physical quantity. These are few examples for the physical quantity. For example, fever. Can we say this fever as a physical quantity? Can we measurable this one? No. So we can't measure the fever, right? So we can measure the temperature of the body. If the temperature is 100 or 101 degrees Celsius, then we call that one as fever. That is, we can measure only the temperature, not the fever. Hence, fever is not the physical quantity. Right? So this is the difference between the physical quantities, that is the quantities which are measurable here, those quantities are called as physical quantities. The quantities, for example here fever, so fever we can't measure, hence this fever we don't call that one as the physical quantities. Here in the fever we are going to measure the temperature. So temperature is measuring by the use of the thermometer. Hence, the temperature is an example for the physical quantity. Hence, temperature is a physical quantity, right? So understand this one. Fever is not the physical quantity because fever we are not going to measure. Similar way, happiness, sad, angry, these are the quantities which are not going to measure. Hence, those are not we are studying in the physics, right? So this is the example for not a physical quantity, and these are the example for the physical quantity, right? So next here, measurable. That is, we start with the measurement because the physical quantities which are measurable are called the physical quantities. So what is measurement, right? measurement. The quantities which are measurable, that quantities are called physical quantities. Then what is measurement? So measurement is nothing but we have to know the unknown quantity, that is the quantities which can be compared of unknown physical quantity with the known fixed value. That one we call as measurement. So what is measurement? So measurement is the comparison of unknown physical quantity. That is, measurement is the comparison of unknown physical quantity with a reference standard. So this one we call as unit. Right? So this is the definition of the measurement. So what is measurement? So measurement is the comparison of the unknown physical quantity. For example, here these are the examples of the physical quantities. I am going to measure this width, that is the unknown of this board width, right? That is length or width of the board. So unknown physical quantity with a reference standard, so we are comparing with this reference standard, then we get the measurement of the board, right? So for example, I am considering this pen as a standard reference, right? For example, I am saying this pen I am going to consider the reference standard. So this reference may be arbitrary, right? So this reference may be arbitrary. So arbitrary is nothing but we can take pen, we can take any other materials, that is scale, or we can take pencils, right? So these are called the arbitrary, that is reference. For here I am going to consider the, for reference standard I am taking this pen. So by using this pen I am going to measure the width or length of this board. So if you observe here, I can make here it is 1, and again by using here 2 and 3, right? 4, 5, 6, 7. So by using this pen, I can measure this length of the board. That is length of the board, that is equals to how many times from here to here the pen is, that is 7 times of the which one, that is the standard unit. We are referring the pen as a standard unit, then the length of the board is 7 times of the pen, right? So this gives the measurement of this board in terms of the pen, that is 7 times it is contained, the length of the board contains 7 times of the pen. So are you understanding this one? So comparison of the unknown physical quantities with a reference standard. So here we can, reference is nothing but the arbitrary, we can take any one, right? For example, here I am taking the pen as the reference standard. By using this reference standard, I measured the width of the board or the length of the board. It gives 7 times of this pen, right? For example, here another example. This one is the length of the pen. That is, this one is the pen. Then, if I measure the length of this book, considering this one as book. So if you observe here, this one is, it becomes 1 and here it becomes 2. Then the length of the book L is equals to 2 times of this pen, right? So we can also take this one. So here pen becomes the standard unit, right? So here the length of the board is equals to 7 into pen, right? So by using this, in general we can write, so this one is the length of the board, that is length is the physical quantity, right? So here the magnitude of physical quantity, that is equals to, right? So by using considering this example, so we can write in the general form, that is the magnitude of the physical quantity, because length is the physical quantity, hence we can write the magnitude of the physical quantity, that is equals to, here 7 is what the numerical value, that is the magnitude of the physical quantity is equals to numerical value into, so this pen we considered as a standard unit, so that is unit, right? So this is the general form for the measurement, right? The magnitude of the physical quantity is equals to the numerical value into its unit, right? So if we write the magnitude of the physical quantity can be taken as q, or any variable, that is p or q, that is equals to numerical value, so I am taken this one as n, right? The first letter of the numerical value is n, hence I am taken n into keeping as this unit, that is u. So q is equals to n into u. So this is not x, this is into n into u, right? So this is the first formula in the physics, right? So this is the basic, and also it is the first formula in the physics, right? So q represents what? The magnitude of the physical quantity, n represents the numerical value, and u represents the unit of that physical quantity, right? So for this standard, the characteristics of the standard, here I am considering only for the example purpose, I am taken this standard as pen, right? For standard, the characteristics of the standard unit, right? Characteristic of standard unit. So what are the characteristics? So in that first one, it is internationally acceptable. So if I am considering this pen as reference here for the standard unit, so this pen has to be acceptable all over the world, that is in each and every country, considering pen as the measuring unit for the length. So the first one is the, it should be internationally acceptable, right? So the meaning of this one is that it should be internationally acceptable means this standard unit must be, if I take this pen as previously considered the example like pen, right? So this pen must be taken acceptable by all over the countries for the measuring unit, right? So if it is acceptable means then I consider the measuring unit is the pen, right? If they are not acceptable means it is not valid, right? So the first point is it should be internationally acceptable. Next, it should be easily available, right? It should be easily available. The standard unit which we are going to use is, it should be easily available throughout whole world, or everywhere it should be easily available. Then only we can say that one as the standard unit. Next, it should be invariant. So invariant is nothing but it does not changes with respect to time. That is, does not change with respect to time. Right? So for example, if I consider standard as one tree, right? So by year to year, the length of the trees goes on increasing. Then as the time changes, the length of the trees also changes. Hence, we not consider that type as a standard unit. For example, I am saying that is invariant is nothing but it does not change with respect to time. For example, it is tree. If I consider the tree as a standard unit, as time changes, as years passes on, then the length of the tree is also goes on increasing. Then we can't say that tree is a standard unit. Similarly, ice cube. If I consider any ice cube as a standard unit, as time passes, the ice cube goes on melting. Then its size goes on decreasing. Hence, also we can't say the standard unit. Ice is also a standard unit, right? So third one is important is it does not changes with respect to time. That is invariant. It should not be invariant, right? And the next one, it should not be too small and it should not be too large for comparable with the other physical quantities. The fourth one is it should not be too small and it should not be too large for measuring the physical quantities, right? That can say that it should be convenient size, right? For if I fix the standard unit, that one should not be too less and it should not be too more. Hence, that one we have it should be in convenient size. So these are the characteristics of the standard unit. We have to remember this one, right? So it should be internationally acceptable and it is easily available and it is invariant, that is it does not changes with respect to time and it is convenient in size, right? So these are the characteristics of the standard unit. Next, one more point is it should be well defined. That is, it should be well defined, right? So this one is the last point, that is fifth point. So these are the characteristics. So by using considering these characteristics, we will fix the standard unit, right? So these are the characteristics of a standard unit. Next, if I move on, for three students, I am going to tell that you have to measure this length of the board, right? To measure length of the board, right? I tell to three students to measure the length of the board, right? So one student measured this length of the board as that is L, that is equals to 2 meter. So one student measured this length of the board and tell that the length of the board is 2 meter. So here 2 is the numerical value and meter is the unit of the length. That is the standard unit of this physical quantity, right? So next, the another student, second student tell that the length of the board is 200 centimeter, right? So here is the first student explain tell that the length of the board is 2 meter and the second student tell that the length of the board is 200 centimeter and the third student 2000 millimeter, right? So the three students give the measurements of the board as 2 meter, 200 centimeter and 2000 millimeter. So these are all the correct values of the measurement of the board, that is length of the board. All the three values are correct. All the three values are correct. So here, if we observe here, 2 is the numerical value and meter is the unit, and here 200 is the numerical value, centimeter is the unit, and here 2000 is the numerical value and millimeter is the unit. So by observing this, we can write this one as, for first student we can write this one as n1 u1, right? The numerical value for the first person, first student is 2 meter and its unit is in meter, that is u1, that is equals to, for the second student it should be u2 and n2 into u2, right? So for the third one, that is n3 u3. As these three measurements are the correct measurements, then we can say that these values are equals to constant, right? We can say the three values are constant, right? 2 meter is also correct, 200 centimeter is also correct, and 2000 millimeter is also correct. That is, we have the length of the board in three different measurements, that is 2, 200 and 2000. The numerical values changes. We can write that one as n1 u1, n2 u2, n3 u3. That one is also equals to constant. So here we can write nu is equals to constant. From this we can write the numerical value into its unit is always equals to constant. And one more thing, if you observe here, 2 is what? The numerical value, and meter is the unit, and 200 is the numerical value and centimeter is the unit, right? So if you observe here, comparing the numerical values, that is 2 and 200, right? So if you compare these two numerical values, so which one is greater? 200 is greater, that is n2 is greater than n1, right? So if you observe for u values, that is units, so meter and centimeter, right? So by this we can say that if the numerical value is large, then its unit must be less, that is centimeter is less. So if I write here u2 is less than u1, right? So if you observe here, if we increase the, that is by comparing these two values, 2 meter and 200 centimeter, as the numerical value 200 that is n2 is large, that is a pair of mark increases means larger value, n2 is larger value, then its unit n2, that is u2 value is less, right? So here if we compare these two means, here the value of n1, the value of n1 is less, right? So if we observe here, the 2 value is less than that of the 200, then n1 value is less, then u2 value is more, right? So are you understand this one? By this what we can say here is, this one is the constant value, that is q. So if we take n is equals to constant divided by u. So we can write, generally we can say that n is equals to 1 divided by u. in general form. Here is the constant value, right? So we can write n is equals to 1 divided by u. So u is inversely proportional to n. So if u value increases, n value automatically decreases. So if u value decreases, then n value automatically increases. So by using this, we can write this one. N is equals to 1 by u, right? So if we observe here, example also will be here only. So 200 is the numerical value, so it is larger compared to 2. So hence if 200 is more, then centimeter is less, right? So understand this one. So or we can write by using this relation, n1 by n2 is equals to, for two variables we can write n1 by n2, that is equals to u2 divided by u1, right? So this one is the concept. So if the unit is, the numerical value is more, then its unit is less. If the unit is less, then its unit is, numerical value is less, then its unit is more. So consider one more example for energy, that is 4.2 joules, that is equals to 1 calorie, right? So already we know, this is the joule is the unit of energy and calorie is also the unit of energy. So if you observe here, 4.2 joules is equals to 1 calorie. So if we observe, comparing these two, the numerical value 4.2 is greater than 1, then we can say that the unit joule is less than that of the calorie, right? So understand this one. The numerical value of joule, this one is more, hence the joule is, the unit joule is less compared to that of the calorie, right? So understand this one. 4.2 joules is equals to 1 calorie. So if we compare 4.2 with 1, so which one is greater? 4.2 is greater than 1. Hence, its numerical value is more, then its unit is less. So here, observe, the numerical value is more, then its unit is less, right? So if we take one more example, that is 1 electron volt is equals to 1.6 into 10 to the power of minus 90 joule, right? So this is also the unit of energy. So 1 electron volt, this one is used, we are used in atomic physics and nuclear physics. So 1 electron volt is equals to 1.6 into 10 to the power of 19 joule. So if we compare here, so here we have 10 to the power of minus 19, then its value is very, very less, right? So initially we can say like this, but it goes to the denominator, then it goes to cross multiply, then its value becomes 10 to the power of 19, 10 to the power of 19 electron volt, that is equals to 1.6 joules. Now if we observe here, which one the value is more here, that is the numerical value 10 to the power of 19 is more compared to that of 1.6, right? Then, so this is about the measurement. So the important we have to know is nu is always constant. By explaining or by using this example, we can write n1 u1 is equals to n2 u2. This is also standard. So by using this one, we can write n1 by n2 is equals to u2 by u1. So if we know the numerical values of the two quantities, then we can find the unknown unit. Or if we know the two units, then we can find unknown numerical value of the two quantities. So in this, you have to remember is the magnitude of the physical quantities equals to numerical value into unit, and this value is always equals to constant. So here is the one example, length of the board measured by 3 students, that is 2 meter, 200 centimeter and 2000 millimeter. So by this we can write, comparing these two values, the numerical values, in which quantity the numerical value is more, then its unit is less. In which quantity the numerical value is less, then its unit is more. Right? So next, the physical quantities further divided into two quantities. The physical quantities which are further divided into two quantities. So one is fundamental quantity and another one is the derived quantity. The physical quantity is classified into two. So one is fundamental quantity and the second one is derived quantity. So what are fundamental quantities and what are derived quantities? The physical quantities which can be, so these are the physical quantities. These physical quantities which are independent from the other physical quantities. So that quantities we call as fundamental quantities. So fundamental quantities are the physical quantities which are independent. That is, the fundamental quantities are the physical quantities which are independent from other physical quantities, right? So that quantities are called as fundamental quantities. So what are fundamental quantities? The fundamental quantities which are independent from the other physical quantities and we can't derive, that is we can't tell these fundamental quantities by other physical quantities, that is these are not expressing by other physical quantities. So that quantities we call as the fundamental quantities. So for example, the fundamental quantities are, that is length, mass, time. So these are the fundamental quantities. So fundamental quantities, so these are the quantities, that is these are also the physical quantities, but these quantities are independent from other physical quantities. We can't define these quantities by using other quantities, right? So that quantities we call as the fundamental quantities. So next, what are derived quantities? So derived quantities are also the physical quantities, but we define the derived quantities by using the fundamental quantities, right? So derived quantities are also the physical quantities. We define derived quantities by using fundamental quantities, right? So what are derived quantities? So derived quantities are the physical quantities which we define those physical quantities by using the fundamental quantities. That one we call as derived quantities. Here is the, we define physical quantities by using the fundamental quantities, right? So that one we call as the derived quantity. So example for the derived quantities are If we take one example, that is speed. So how we define speed? So speed is a derived quantity. Means speed is also a physical quantity. We need to define the speed by using fundamental quantities. So by the definition, speed that is equals to distance by time taken. Right? So speed is defined as distance by time taken. So distance is what? Distance is nothing but length. So length is the fundamental quantity, and also time taken, that is an object moving from one place to another place, it takes some time, so that time is also a fundamental quantities. So we can define the speed by using the two fundamental quantities, hence speed is called as the derived quantity. So here distance and time are the what? Those two are the fundamental quantity. So if we take one more example, that is force. So force can be defined as mass into acceleration. Mass into acceleration. Right? So force is defined as mass into acceleration. Again, here mass is what? Mass is the fundamental quantity, and acceleration. So we can acceleration can define in terms of fundamental quantities. Then what happens here is mass into acceleration is nothing but velocity divided by time. Right? So mass we get the fundamental quantity, and also here we get the time as the fundamental quantity. Then we need to define the velocity. So velocity is nothing but the speed. Then velocity can be written as, so here I will write, that is force is equals to mass into, this is in the denominator, that is mass divided by time into velocity can be written as displacement divided by time. Right? So displacement is also nothing but length. So here we have the four physical quantities, that is time we have two times, then we can write time into time, that is time square. Mass into displacement divided by time square. So here we have three physical quantities. So these three physical quantities are the fundamental quantities. Hence we can say that force is a derived quantity. By using these fundamental quantities we define the force. So mass is a fundamental quantity, displacement that is nothing but the length, and also time. So time is also a fundamental quantity. So likewise, so here in this example only we define the acceleration. Acceleration is also a derived quantity. So acceleration is equals to displacement by time square. So displacement is also fundamental quantity, time is also a fundamental quantity. Then we say acceleration is also a derived quantity. So this is about the physical quantity, that is classified into two, fundamental quantity and derived quantity. Next, unit, that is what are units? So units. So what are units? So units are the standard of measurement, that is the quantity used as a standard of measurement is called unit. The quantities which are used standard of measurement, so that one we call as unit. Right? So what are units? So the quantities used for the standard of measurement, right, is called units. This is used in the standard of measurement. So this one we call as units. So what are units? The quantities used in the standard of measurement. So example of the unit in the last we discussed that standard, that is characteristics of the standard are units. So this can be internationally accepted and these are easily available and it should not be invariant. So the example for that one is meter, next kilogram, next second. So these are all the units. So these are all the example for the units. These are the quantities, right? So which are used in the standard of measurement. So here meter we are going to use for the measurement of the length, right? So length is a physical quantity. The quantities here, the meter is also the quantities which are used in the standard measurement. So for the length, we are going to use meter for the measurement of the length. So similarly, kilogram is used for the measuring of mass, and second is also used for measurement of time, right? So these are all the units. Example for such units are meter, kilogram, second, right? So these are the few examples for the units. So again, units are classified into two. So first one is fundamental unit, and second one is derived units. So what are fundamental units? So fundamental units are nothing but the units which are used to measure the fundamental quantities. So that one we call as fundamental units. So we can simply say that fundamental units are the units which are used to measure the fundamental physical quantities. So that units are called as fundamental units. So here the fundamental quantities are length, mass and time. So these are the few examples we taken, right? So these are the fundamental physical quantities. So for these fundamental physical quantities, we are going to use the measuring units that are meter, kilogram and seconds. Then we say these are called as fundamental units. The units which are going to measure the fundamental quantities. That units are called as fundamental units, right? So next, similarly, derived units, the units which are going to measure the derived quantities, then we say that units are called as derived units. So for that we have example, that is meter per second and meter per second square. So these are the few examples of the derived units. So here meter per second is the derived unit for the derived physical quantities. For example, if I take speed, so speed is the derived physical quantity. So speed can derived by using distance by time, right? So here distance is the fundamental quantity, time is also the fundamental quantity. So the unit of the distance is nothing but length. The unit of the distance is meter divided by, keeping for the time we have the unit is second. Hence the speed is the derived physical quantity, then meter per second is the derived unit. So in symbols we can write meter per second as meter divided by s. M represents meter and s represents seconds. In the similar way, this is meter per second square is for the acceleration. For acceleration, we can write, so acceleration is equals to velocity by time or displacement by time square, right? So displacement is also nothing but the length, so the unit of the displacement is meter, and time, the unit is second divided by second, it is in squares, so hence we can write meter per second square, right? So these are the examples for the derived units, the units which are derived from the fundamental unit, then also we say that one as derived units, or we can say the units which are going to measure the derived physical quantities, then that units are called as derived units, right? So in the next class, we will continue the class. Thank you.